All right, so here we go with our test review, Unit 3. We're doing moles, molecules, atoms, ions. We just had our quiz. Some of you are still letting things go. You know, you're not understanding it. You're letting it go. It's not going to get better. Take responsibility. Figure these things out. Watch it 100 times. Ask questions. Know where these numbers are coming from. And fix your mistakes. All right, so the first question is we're going from ions inside of magnesium phosphate to moles. All right, so my conversion has to be from ions to the fundamental unit, then from the fundamental unit to moles. That's Avogadro's number. So I can't say there are 6.02 ions because that is not the fundamental unit. This is a formula unit because it is ionic. It has a metal. So in one formula unit, I have 3 magnesiums and 2 phosphates, so 5 ions. So my first conversion is there are 5 ions in one formula unit. Then I can say there are Avogadro's number of formula units in 1 mole. So that is the conversion for that. And the important part there again is knowing what the fundamental unit is. And that's how you get to moles. And when you have ions, it is not the fundamental unit. So you can't use Avogadro's number right away, but instead have to get to formula units before you can use it. I also said if you have 10 to the 40 something, that is not right. You're not putting your calculator in right. So 8.31 times 10 to the 24th divided by 5 divided by 6.02 times 10 to the 23rd. So I get 2.76 moles of magnesium phosphate. Okay, so I didn't even need grams there. If I asked for grams, then the last step would have been convert moles to grams using the molar mass, but I didn't ask for that. And the next one, though, we start with grams, 7.39 grams of water. So from grams to moles, I need the molar mass. The molar mass of water is 18, 1 O, so oxygen 16, 2, so 18 grams in 1 mole. So now I have moles. Now the fundamental unit of water is molecules, because it's ionic. So 1 molecule will equal how many atoms? Well, 3 atoms total. 2 atoms of hydrogen and 1 atom of oxygen. But it just says how many total atoms. So in order to use that, then, I have to get to molecules. So 1 mole, the fundamental unit is 6.02 times 10 to the 23rd molecules. And then in 1 molecule, I have 3 atoms. So that goes from one extreme to the other in the calculations we've been doing. 7.39 times Avogadro's number. And then times 3. And then divided by 18. And we got 7.41 times 10 to the 23rd atoms inside of that many grams of water. Okay, next one. 81.90 grams of BaCl2. So BaC or Cn parentheses 2. So that's barium cyanide. We need a molar mass. So barium is 137. 2 carbons times 12. 2 nitrogens times 14. Add them up. We get 189 grams per mole. So there's the molar mass of that. So 189 grams in 1 mole of barium cyanide. Now I have moles. The fundamental unit is formula units. There's a metal, so it's ionic. So 1 mole is 6.02 times 10 to the 23rd formula units. So 81.9 divided by 189 times, and we got 2.61 times 10 to the 23rd formula units. All right, next. So now the next thing is basically the same questions, just in a table form. So the molar mass, so we're doing the molar mass of sugar, so 12 carbons, 144, 22.22, 11 times 16, 176. Add those up, and you get 342.2 grams per mole. So 342 grams per mole. You could keep the 0.2 if you'd like. We're given moles. So 0.70 moles. 1 mole is 342 grams. That's going to give me the mass. So 0.75 times 342 is 257 grams. So there's A. Now B, I have moles. Now notice I skipped this column. I'm asking for atoms or molecules. In here would go, atoms or ions. In here would go molecules or formula units, but we're not asking that. I'm asking you to tell me how many atoms or ions. Well, this is a molecular substance. They are all nonmetals. So since they're all nonmetals, I'm going to say 1 mole is 6.02 times 10 to the 23rd molecules, the fundamental unit. And then in 1 molecule, I have 12 carbons, 22 hydrogens, and 11 oxygens. So 12, 22, and 11. And we get 45. So there are 45 atoms in that 1 molecule of sugar. So 0.75 times 6.02 times 10 to the 23rd times 45. So 2.03 times 10 to the 25th atoms. And again, I'm going kind of quick here because they're exactly the same as the others. You can rewind them, watch them again. 7.98 times 10 to the 24th. Now I have NaOH. That is ions. Why ions? I have a metal. Metal makes it ionic. So that is an ionic substance, therefore I have ions. Now the fundamental unit is formula units. And remember with polyatomic ions, so there's OH again. We've done that now several times. We have 1 Na and 1 OH. So that is 2 ions in 1 formula unit of NaOH. 6.02 times 10 to the 23rd formula units in 1 mole. And that will give me D, moles. And then the last step is going to be 1 mole and the molar mass. 23 plus 16 is 39 plus 1 is 40. So we have 40 grams per mole. So 40 grams per mole. So there's the complete setup. The answers are going to be 7.98 times 10 to the 24th divided by 2. That'll give me formula units. Divided by 6.02 times 10 to the 23rd, and that's going to give me moles. So I have 6.63 moles. And then times 40, I have 265 grams. All right, so that's one type of question we have, dealing with Avogadro's number in moles and molecules, the fundamental units, formula units, and then atoms and ions. All right, the next kind of calculation we did was a molarity question. So molarity, in a lab you have measured 50 milliliters of a 0.75 molar NaCl solution. How many grams? Well, our formula for molarity is molarity equals moles divided by liters. Now, some of you put grams in there, but when I did this, that was not my intention that we put grams in there. You have to have moles in the formula. But in the problem, if you're asked for grams, you can convert grams to moles and moles to grams using the molar mass. But in this formula is moles, not grams. And so we're looking for grams. So the way we're going to get there is we're going to calculate moles. We're going to do that by saying, remember if I put my hand over the moles, it is equal to molarity times liters. Equals the molarity right there above the number, 0.757 molar. Times, this is milliliters, so I need to go 1, 2, 3 to the left and make it 0.0500 liters. Now that gives me moles, so 575 times 0.05, and I got 0.0288 moles. And then how many grams? Well, it's NaCl, and I kept all of these problems NaCl, so you didn't have to continue to do molar masses. The molar mass of NaCl is 58.5. So that times 58.5. Now you can see I kept all of the significant digits there, so you may get a slightly different decimal than I got. 0.168, capital M for molarity. So 1.68 molar solution of NaCl if you have that concentration. I'm sorry, that would be grams. Oops, not molar. Something was wrong there. 1.68 grams of NaCl. We solved for mass. Sorry, we already had the molarity. All right, so number 4, what is the molarity of? So once again, we have a volume. This time we have ions of sodium. All right, so in order for me to do molarity, I need molarity equals moles divided by liters of solution. So I need moles. I'm given ions. So similar to those first type of questions, if I have that many ions of sodium in my solution, I need moles. Well, there is 1 sodium ion in 1 formula unit of sodium chloride. Then 6.02 times 10 to the 23rd formula units in 1 mole. So there's how I'm going to calculate the moles of NaCl so that I can divide it by the liters. So 9.75 times 10 to the 23rd divided by 9.75 times 10 to the 23rd divided by 6.02 times 10 to the 23rd. Oh man, let's try that again. 9.75 times 10 to the 23rd divided by 6.02 times 10 to the 23rd. There's my moles. What is going on? One more time. Take my time a little more this time. 9.75 times 10 to the 23rd divided by times 10 to the 23rd. Hooray! 1.62. So 1.62 moles. So now looking at our formula, this equals 1.62 moles divided by, we have milliliters, so 1, 2, 3 to the left again, 0.2500 liters. 1.62 divided by 0.250 liters, 6.48. Now this one's definitely, we're solving for molarity, so molar, 6.48 molar solution would be the right answer for that one. All right, so if you dissolve 2.31 grams of NaCl in enough water to make, so we have grams, we have centimeters cubed, we're looking for molarity. Molarity equals moles divided by liters. We're going to change 2.31 grams to moles. 2.31 grams of NaCl, molar mass, is 58.5 grams in a mole. So to go from grams to moles, I need the molar mass. I have 2.31 divided by 58.5, and I get 0.0395 moles. So I have the moles. I need liters. Well, I'll move it over 3 again. I have 25, so 0.025 liters. So take my moles and divide it by my liters. And I get 1.58. Again, this is a molar solution. We're solving for moles. Got it. All right, next one. Again, molarity. This time I have moles. I have decimeters cubed. 1 decimeter cubed equals 1 liter. Centimeters cubed, remember, equals milliliters, like the previous question. Decimeters cubed equals a liter. So molarity equals, just like before, moles divided by liters. So 3.21 moles divided by 9.71 liters. So that's about as easy as it gets. I had moles and I already had liters, so I didn't have to do any converting. And I got 0.331, capital M, molar solution. Next one. Next one kind of tests your understanding of molarity. A 2.0 molar solution of NaCl. So I have in a beaker, 2.0 molar solution is dissolved in water and left in an open container in my lab for a week. So a week goes by. The water level is going to drop. The question is the concentration going to be greater than or less than 2? Well, the whole understanding of this is the water is evaporating, but is the salt? Does NaCl evaporate? And the answer is no, it doesn't. So if you have that many particles of NaCl in that one, you're going to have the same amount of NaCl. So molarity equals moles divided by liters. The moles are going to be unchanged, but the liter of solution is going to be less. So if you're dividing by a smaller number, the answer is the molarity is going to be greater than the original 2.0 because you're dividing by less liters of solution. And the key to that is understanding that the water evaporates and leaves, but the salt doesn't. So it has the same amount of moles. The only thing that changes is the amount of water. All right, calculate the formula units required to make. Oh, formula units. We know how to get there from moles. So I have centimeters cubed. I have molarity. Moles equals molarity times liters equals 6.21 molar times, again, centimeters cubed, so 3 to the left. So 6.21 times 0.75, 4.66. So I get 4.66 moles of NaCl, formula units. 1 mole is 6.02 times 10 to the 23rd formula units. So times 6.02 times 10 to the 23rd, and I got 2.80 times 10 to the 24th formula units of NaCl. Sticking with NaCl again, less molar masses. Calculate the grams needed in the preparation of. So now, once again, we're doing a solution. We have the molarity. We have the liters, well, the milliliters. So moles equals molarity times liters. 3.00 molar times, move it over 3 spots. 1, 2, 3 spots makes it 0.05. So 3 times 0.05. And we get 0.15. Yeah, that was an easy one. 0, add the significant digit. Moles. And then grams. 1 mole is 58.5 because it is NaCl. Grams. So times 58.5. 8.78 grams of NaCl. So that's the first part of the question. Calculate the grams. Now explain how you would make it. There was a sentence that I gave you. I'm running out of space here, so I'm just going to kind of fit it here. It is dissolve that many grams, so 8.78 grams of NaCl in enough water to make 50 milliliters of solution. And there's what the other blank would be. So if we were going to use a different substance, it would just, the difference would be how many grams we calculated and whatever the volume was given in the question. So dissolve 8.78 grams of NaCl in enough water to make 50 milliliters of solution. The last bit. Well, actually, another molarity. So this was just a lot of repetition. We're looking for moles. We're given a centimeters cubed in molarity. So moles equals molarity times liters. 1.75 molar times 0.0250 liters. So once again, centimeters cubed, same as milliliters. So 3 to the left. 1.75 times 0.025. And we get 0.0438 moles. And I think it said moles. So you're done. If it asks for grams, once again, the molar mass. And we'd get grams. All right, so notice we've changed now. We're on number 6. How many grams of a gas will occupy at STP? So there's that 1 mole equals 22.4 liters of any gas at STP. So we're no longer talking about molarity. We're no longer talking about something dissolved in something else. We're now talking about the volume of a gas at STP. So there's the key phrase. And I'm starting with milliliters of SO2. And I want to know grams. Well, I can do liters to get to moles. So 1,000 milliliters in 1 liter. Or I can move it over 3 and make it 0.750. Now I have liters. So 22.4 liters is 1 mole. And now I got moles. Liters cancels, milliliters cancel. I have moles to grams. I need the molar mass of SO2. 32.1, 64.1 grams in 1 mole. The molar mass of 1 S and 2 O's from the periodic table. So 750 times 64.1 across the top, divided by 1,000, divided by 22.4. And I got 2.15 grams of SO2. So again, the only time we can use that is a mass, or a gas at STP. A gas at STP, 1 mole equal. There it is again, at STP, the density of O2 gas. So density equals mass over volume. Now what we're going to do is assume a mole here. So we're going to use the molar mass of 2 iodines, 127 times 2 is 254 grams, divided by the volume at STP, which is 22.4 liters. So 254 divided by 22.4, and I get 11.3 grams per liter are the units. Grams and liters don't cancel. What does STP stand for? It is standard temperature and pressure. T is temperature, P is pressure. What is the molar mass of a gas with a density of? Tricky one here. Molar mass is measured in grams per mole. This is sort of a test of your dimensional analysis skills. If I'm given 0.955 grams per liter and I want to end up with grams per mole, that means I want to start with grams on the top. And if I do that, grams per liter puts the liter on the bottom. Now, this is a gas at STP. So 22.4 liters equals 1 mole. Why did I put that up there? Because liters and liters cancels. I have grams per mole. So 0.955 times 22.4 gives me 21.4 grams per mole. So again, a test of your dimensional analysis skills. Have you been learning what you needed to learn to figure these problems out? There's a great example of it. You didn't really have to know how to solve that problem, but as long as you started with grams in the right place and know that per liter means the liters goes on the bottom. So now I have grams on the top, liters on the bottom. So the gas at STP will get me from liters to moles. So I want to put the liters on the top so it will cancel. And then I end up with grams per mole. So again, there's the power of the dimensional analysis. What is wrong with the statement, I have 3 ions in the compound SO2? What's wrong with that is it is a molecular substance. And so it should not read 3 ions. It should read 3 atoms because they are nonmetals, and that would be a covalent bond. All right, so there it is. Good luck.